Hey guys, welcome to another video. So today we're going to do another video in the nice question series. Today's question comes from the Extension 2 syllabus under the mechanics topic. So the question today relates to projectile motions with resistance, right? So a lot of people, a lot of schools do this as the very last topic in their 4-unit syllabus. And because they're doing it at the end, they generally don't spend a lot of time on it, right? The question I have for you today is from the Norman Hurst 2021 trial paper. It's 7 marks, so very heavy for a 4-unit paper, seven marks, 7% of the test. So let's dive into, actually, before I dive into it, if you haven't already done so, please like the video, subscribe to the channel, and tell your friends, as always. So let's get stuck in. So question from Norman Hurst looks like this, where the question says a projectile, okay, projectile motion, launch with the launch from the origin. That's important, right? Initial conditions there, when t equals 0, x equals 0, y equals 0, with velocity, that's initial velocity as well. So this here is good because that gives us the initial conditions, right? As you're reading through this, just pick out the parts that are important. So for example, subject to gravity and air resistance, right? So this is one of those projectile motions that sort of falls short of a full parabola. So it sort of looks like a bit of arc, bit of drag, they call it. Now let's see what type of drag it is. The magnitude of the air resistance is mkV, right? So it's linear drag, right? So mkV is the resistance both on the horizontal and the vertical, right? Mass. Show that the position vector, so they want me to find displacement, right? Yep, equals to that. Easy, hence Cartesian. Okay, cool. So I would say this question, even though it's in the last harder part of the syllabus, it's very textbook, right? So they just want me to derive the position vector or the displacement equations and then Cartesian. So let's get stuck in. So part I, right? So with this, please note, actually, maybe I'll start here, right? When t equals 0, right? Starting from the origin, I know that, displacement-wise, x equals 0, y equals 0. And initial velocity-wise, y0, y dot equals to v0. Is that v0? Yep, v0. Okay. Cool. Just want to see if that, yeah, that says v0. Okay, cool. So we go with what we always do, right? We say that because this is launched from the origin. Now, if I drew a very brief diagram, right? Projectile there, right? So we know there's gravity going downwards and also resistance or drag, in this case is mkV, right? That's important. So horizontally, we normally don't have any acceleration, right? If it's a normal sort of unresisted projectile, but now we have negative mkV. So we start there, right? So horizontally. Right? We got x double dot equals to minus mkV. Yeah, now mkV, so maybe we won't use v, is that right? Maybe I'll use mk x dot, right? Just to show that it's the velocity on the x value, because later on we'll have velocity on the y, right? So in this case, we know that this is dv dx, sorry, dv dt, sorry, equals to negative mkv. So if I leave the mk, they're constant on the other side, and I sort of switch, right? So swap these guys, put these guys together, and put, using my differential equations, put these guys together on one side, you get like 1 on x dot, or 1 on v, right? And that's dv minus mkv dt. And then I integrate both sides, right? So I integrate this side here. And then because these are constants, I can easily integrate that there. You know what? I put the integral sign here, same thing, right? Same effect. So I get ln x dot here equals to, what's that, minus mkt plus, now the first constant. Nothing hard, right? Now, some students really prefer to use v here, so you can write v with a little x, same thing, right? I just use x dot. Now, so at this junction here, maybe worthwhile to find the constant. So when, sub in your initial conditions, when t equals 0, I know that x dot equals to u0. That's what's given in the question, right? Yeah, so if you sub all that in, 0 there, so it looks like C1 equals to ln u0, right? So then I would sub this guy. Now let me give it another color. Back into here, right? And then therefore I get ln x dot equals to negative mkt plus ln u0. Now, what am I trying to do? I'm trying to make x dot the subject, right? So I'm going to combine it with combine the ln's and then exponential both sides. So if you combine the ln's, you still get like x dot here over u0 equals to minus mkt. And so therefore, making x dot the 0, sorry, x dot the subject, exponential both sides times u0 up, it'll be u0 e minus mkt as my velocity, right? Quick check, perfect, right? U0 minus, oh, how come I got m here? Let me see, should m go away? Ah, yeah, sorry, my bad. So at the start here, it's not acceleration, it's ma, right? And then you should actually get rid of that, yeah? So all the places with m, my apologies, let's get rid of it, right? Makes it a little bit cleaner. Yeah, should be no m's involved because m would have cancelled out from the start. Yeah, my apologies. So once you do that, perfect, right? Now we need to do displacement. So once you get that dx dt then, which is velocity, equals to u0 e minus kt. Yeah, once again, times that up and integrate both sides. So well, let me just do it all in one step. X equals to the integral, right? Of u0 e minus kt dt, which is very easy integral, right? Oops, at the very bottom. So do I have? I think I do. Little space here. Oops, didn't capture integration sign. Let's move it up here. All right. Let me just check that. Yep, perfect. So just going to integrate that becomes u0 divide by so e minus kt all over negative k plus c2. Is that right? Yeah. So when t equals 0, x equals 0. Now what do I have? That's 0. This guy is 1, so it becomes negative u0 on, so c2 equals to positive, right? Because you throw it over the other side, and then we once again sub that into here. And then now, please tell me I've got a bit more. One more. Oh, damn! I need one more line. You know what? Maybe I'll just go therefore x equals to. So when I sub it in, I'm going to factorize a u0k out, so it becomes u0k. Actually, let me look at my question. Just make sure. U0 on k, perfect. All right. U0k, and there will be 1 minus e minus kt. How's that? Yeah, so that's the x value, right? That's done for that one there. Now let's do what vertically, right? So you know what? I quite like having all my working out all in the one place. So what I'm going to do, if I do this, I'm just going to move this diagram over here. That's okay. I'm just going to do a bit of gymnastics here with that. Let's go over here. Perfect. All right, let's carry on. Hope that was okay, guys. Let's go vertical, right? So vertical, it's the same deal. Sorry, MA in this case equals to, normally it's negative mg, right, for gravity. But now I've got actually, yep, negative mg, and then I've got resistance as well, negative mkv. Let me just quickly check that. Perfect start. Right, delete all the m's. Right, and there I have my equation of motion Whereas now in terms of acceleration, it's actually, I'll replace now in the same step, make that dv dt or dy dot, right? So that's velocity for y minus kv. And if you're amazing, right, you basically identify this as, I'm gonna put the dt, maybe on this side, maybe I'll factorize negative out, right? So when I take it up, I'll be sure to sort of factorize the negatives out. Yep, and then on the other side, I'm gonna go dv, and then it'll be g plus kv, right? I'll be sure to do that. So I'll get 1 on g plus kv dv equals to negative dt, right? Yeah, so I just kept the blues together and the pinks together, integrate both sides. Yeah, now that's an ln, so the way you achieve that, so obviously I would multiply this by k, right? And then go 1 on k outside, because k is my derivative. Now I can reverse chain rule that to 1 on k ln of g plus kv equals to negative t plus c, 3. Yeah, maybe at this point, maybe times a k up before I actually find my constant. Remember, the constant is unknown. So when you times a k with it, it actually doesn't change anything, right? Just still remains at C3. And now initial conditions. When t equals 0, I know that v equals to, was it v0? Quick check on that. I think it is. Yeah, v0. So therefore, when that's 0, and that's v0, C3 equals to ln g plus kv0. Sub that into here. Yep. And you know what? When I sub it in, I'm going to at the same time move it over to the left. So it becomes like ln, that's okay, g plus kv minus, which log terms, where you basically divide 0 equals to minus kt. Yeah, once again, what I'm trying to make, oh, sorry, I wrote v. Yeah, that's pretty naughty of me. So can you please write y dots on these? Y dot, y dot, y dot. Yeah, technically speaking, you could use like v, y or something, right? But since we're using y dots, right? All right, I need to make y dot the subject. It feels like I'm going to exponential both sides and then times it up in this bit of algebra manipulation. So if I e both sides, can I do 2 steps? E both sides times this up, right? So it'd be like k plus, sorry, not k, g plus k y dot equals to g plus k v0 e minus kt. And then I'm going to minus g over. Is that right? Minus g over, yep, and then divide by k. So therefore, y dot equals to minus g and divide by k. So it'll be like g plus v0 minus kt all over g and minus k on g. That is v, yeah, velocity. And then once I get velocity, now I feel like I need more space. So let me quickly move this up. Therefore, dy dt equals to this guy. Yeah, it's not too bad. It just looks messy, but there's a lot of constants here, right? G, K, V0 is all constant. So this just looks like an exponential and a constant that I'm integrating, right? So therefore, when I do this step here and I integrate, right? And I'll just, because I'm lazy, just going to copy and paste that. Integrate this guy, dt, right? And let's see. So like I was saying, everything else is constant, I believe. Just quickly check that. Yeah, so then I just got to divide that by, put the negative k downstairs, so it becomes like negative g plus k v0 e minus kt on gk, right? Is that right? I think that's right. Let me just check that on GK. Yeah. Did I do that right? I feel like I'm missing something. Let me just check my y dot. Make sure that's right. That t equals that. Yep, y looks right. And then dv 0. Huh? I'll divide by k. No, I've got this part here wrong. Right, because this one here, let me see. It's minus g on k. Sorry. Yep, cool. Okay, let me quickly fix that. Got a lot of algebra, right? So hopefully the concept's still fine. Just me making silly algebra mistakes. Just want to clean all this up before I go any further. G on k, k. Okay, so when I do it, then the bottom here actually already had a k, so it becomes k squared. This becomes negative gt on k. Now let me check that. So k squared on that, perfect, split, okay. Minus gt, okay, plus c4, cool. Now, do I have any space? Very tight. When t equals 0, y equals 0, start at origin. Let's see, 0. That's gone. So it just looks like that's 1. So C4 equals to the positive version of this. Yeah, in which case we're going to sub that into C4. And then if you did your mathematics right now, let me just have a quick look. So if I put it up, I feel like I'm going to factorize this guy, which is this, with this. So it becomes like 1 minus e, and then minus that fraction. 1 minus e, perfect, and they split it. Okay, cool. So I can actually go, therefore, y equals to split. So they actually split this fraction into g on k squared plus v0 on just 1k, and then 1 minus e minus kt minus gt on k. Now let me quickly check that. Boom, 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 boom. Is it the same? Boom, 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 minus gt. Okay, cool. Yeah. Guys, that's how you get the x and that's how you get your y, yeah? And then you can conclude that it's in the vector form, but x and y done. 5 marks there. Bit heavy. Apologies for the little algebra error, but that's how you do it, right? Because once you do that, the next part should be fairly straightforward because it's just Cartesian. Right? If you couldn't do part A, right, you still can do part B because all you got to do is, if this is the x value, right, if this guy's x, this guy's y, right, we have to make it Cartesian, I'm going to remove the parameter, right? So in this case, the parameter that we dislike is t, right? So just got to, from x, make t the subject so I can sub it in there. So I go, since x equals to, so this is for part 2. Since x equals to u0 on k, 1 minus e minus kt. Yeah, let's make this guy the subject here. So 1 minus e minus kt equals to kx on u0. Now that's actually quite important because if you look at that, that's the same as this. So I'm going to sub basically this guy here into that pink bit, right? I'll do that in a second, but for now, let's go. Since y equals to g, oh, sorry, I haven't even made t, let me make t the subject here. So e minus kt would equal to 1 minus kx on u0. And so therefore, t would be negative 1 on k, ln 1 minus kx u0. Yeah, okay. So I'm going to sub this guy and this guy into the y value. Now, what's the y value? Y equals to just copy and pasting that. G on k squared plus v0 on k 1 minus E minus KT and minus G on KT. Okay, cool. So the game plan is replace the pink here. So sub this guy into here, and then replace the blue here. Into there, and you go therefore y equals to G plus K squared plus V0 on K times KX on U0 minus G on K times minus 1 on K ln 1 minus KX 0. Quick check. Looks okay, I believe. Except for that minus. How come there's no minus in the solutions? Let me see. If I move. I think there might be a typo in the solutions for the Normanhurst paper, because what they did was they didn't have this minus here. Yeah, but this minus comes from this bit, right? So what did they do? Let me see. Did they reciprocate? They didn't. Yeah. So let me just take a screenshot of the working out here, just to show you what I'm looking at. This is what they had in the solutions. Let's have a quick look at it to see whether it's right. Not sure it's right. So they got, let's see, this line is exactly the same as this line, right? Looking at it, same, yep. And then for some reason, they left out the minus here. So when they made the subject, they left out the minus. Okay, cool. Doesn't matter. This means I'll just proceed with this, because all that changes is that there's a negative here, right? That makes it the plus, that's all. And the solutions, they still have it as a minus. Okay. So when I expand this, they basically they wanted to isolate the x by itself. So you basically go K on U0. Actually, the K come in. I think they wrote it like this: X on U0. They made the K come in and cancel some K's out. So that's G on K plus V0. And then plus, right? Not minus like in the solutions. G on K squared ln 1 minus KX on U0. And that's a Cartesian. Oops, I'm missing the Y. Therefore. How's that, guys? That's how you do this question, which is projectile motions with resistance in the mechanics topic in extension 2. Guys, hopefully that was good. That was okay. Like the video, subscribe to the channel, and tell your friends. I'll see you guys at the next video. See you later. Thank you.